Hey guys, in this video we will see three things. First, what is line graph? Second, why and where line graphs can be used? And third, how to plot line graphs in Python using Matplotlib package. So let's start with first, what is line graph? So line graph is also called as line plots, which is also called as line charts. And line graphs is normally used to display a data using series of data points that are connected by a straight line. Line graph is commonly used to represent a data that changes over a continuous interval. That interval may be a time, maybe a distance, maybe a temperature, or any other continuous variable. It is particularly effective for showing trends and patterns in the data. Now we will discuss second, that is why and where line graphs can be used. So line graphs can be used to visualize univariate analysis or bivariate analysis. In univariate analysis, we have only single variable or single column or single axis. In bivariate analysis, we can have two axes or two variables. And in multivariate analysis, we may have more than two axes, basically more than two variables. And this line graph prefers we can prefer this line graph to visualize univariate and or bivariate data. Normally, it is used to show the trends. You can see in this particular image, this is the positive trend. This is the second negative trend, and this is the no trend. The value of y is constant here. X changes, y is not changing. Here x changes, y changes, but it's going in decreasing direction. That's why it's a decreasing trend or it's a negative trend. Here x changes, y also changes, but it is not decreasing, it is increasing. So this is called as positive trend or increasing trend. Line graphs can also be used to compare multiple data series. So if you have multiple line graphs, you can plot in a graph and you can observe the difference between them. So for example, in this particular case, you can see there are three servers and this is the response time measured of these three servers. So this is server 1, server 2, server 3. This line trend is for server 1, server 2 and server 3. And on Y side, we have a response time and this is basically hours of a day. So from this particular chart, we can easily understand that the server 1 is having less response time compared to server 2 and server 2 is having less response time compared to server 3. So which server is fast? Which server is responding fast? If this is my question, the answer will be definitely server 1, and which is the slow server, then answer will be server 3, and the performance of server 2 is in between server 1 and server 3. Even line graphs can be used to highlight the patterns and anomalies. You can see in this particular image, in this trend, there are a couple of anomalies, extreme points basically, which are very far from other points. So for example, here are the few points, these are the few points, but this point is very far from other points. That's why this can be treated as anomaly. Even here also there are three anomalies, and this to detect these anomalies, we can use this line graph. Now we will discuss how to plot line graphs in Python using Matplotlib package. So let's go to computer. Let me open VS Code. For your kind information, how to install Python in Windows, then how to install Anaconda framework into Windows computer, how to create virtual environments, then how basically we can activate, how we can install VS Code, how to activate virtual environments, how to install VS Code, how to integrate Jupyter Notebook into VS Code. So these videos already we have released in the previous playlist. You can go to the playlist and you can find the appropriate video and you can watch, you can understand from there. So what I have done is now, let me go one by one. So let me show the data set first. So this is the data set, server performance. So imagine a situation where you are working in a company and your company is having multiple servers, and these servers are going to respond to the request. So let me show, let me come back to here. Yeah, let's see this particular scenario. So assume for in your company there are three servers, server 1, server 2, server 3, and your client is basically here. And these are basically different networking components which will be in between your internet and the servers. And here few applications are hosted, and your client is requesting, for example, let's take an example of google.com, right? So let us assume these are the servers of Google, and you are requesting Google's homepage from your this particular machine. So if this machine requests to this particular server one, then is going to this server can give reply back to the client, and the response time for server one is recorded here. You can see these are basically hours 1 2 3 4 5 up to 12, and response time for every request. For first request, the response time was 50 milliseconds, then it was 40 milliseconds for second request, and third, fourth, and so on basically. Similarly, if request goes to second server and response comes from second server to client, this is basically response time from second server, and this is response time from third server. Now a question is, now main thing is, we want to identify which server is fast. Now currently we have only a data of only 12 hours, but you might be in real case scenarios, you might be having data of 24 hours, not only 24 hours, you might be having data of 3 days, 5 days, 10 days, 1 week, 1 month, one specifically year also. So in that case, by observing this particular raw data, it will be difficult to decide which server is fast, which server is slow, and which server having the constant or average speed. So for this, we can plot this data with the help of line graphs. So let me do one thing now. Let me minimize this. Let me go to here and let me show this data which I have taken. I will right click to this particular CSV file. I will attach this CSV file and this particular notebook in my GitHub account. So you can take from there to practice it. So if you right click on this particular CSV file, you might be not getting this open preview button because I have specifically installed Excel viewer extension from this extension box. If you have not installed, you can install this particular Excel viewer extension. You can see the preview button. So what I will do, I'll right click on this. So you can see this is the R, and let me expand this. This is the server 1 response in milliseconds. This is server 2 response. This is server 3 response. And now we need to read this particular data, and we need to go for line graph. We need to plot the line graphs. So what I will do now, all right, we can read this particular CSV also. So how to read a CSV in pandas, right? There is a function. So let me, first of all, let me show you, right, how basically we can check the particular package is installed into your environment or not environment. So here what I have done is basically for if you have already seen my previous videos, then you already aware about how basically we can integrate Jupyter Notebook inside VS Code. If you are watching this video first time, and if you have not seen the previous videos, then you might be thinking that how this Jupyter can be installed, integrated into VS Code. So you can check the video which I have released earlier, which will show you how exactly Jupyter can be integrated into VS Code. After integrating Jupyter into the VS Code, I have activated this particular database environment, and here I am going to run one command, pip show, for example, pandas. I want to check the pandas is available in this particular environment or not. Yes, pandas is available and the version is 2.1.1 and so on. Similarly, if I want to check Matplotlib is present, which is installed right now or not. So let us check. This is also already installed. If it is not installed, then instead of pip show, you can write pip install, right? Pip install Matplotlib, and you can just run the cell. Even you can give this exclamatory mark here, or if you go to a terminal, if you go to command, and you can just write a command here, pip install Matplotlib, then you can install this particular package into this particular environment. So let me delete this now. So I'm going to import this particular matplotlib.pyplot as a PLT. Let us run this particular cell. Yes. Now let us see how single line graph can be plotted. So we have two variables now. The first variable is hours, which starts from 1 to 12, and second variable is response times. This is the first response time for first request, second response time for second request. Basically it's a second request at second 2 o'clock. This is at the 3 o'clock. This is at the 4 o'clock. This is at 12 o'clock, and so on. So similar, we have this 12 response time for each hour. Let's run this, and now let us plot the figure. To plot the figure, we have this Matplotlib package. Inside Matplotlib package, there is submodule named as pyplot, and which is imported as a PLT. So we can create a figure. So pld.figure, the figure size is given as 8, 4. So 8 is basically a width, 4 is basically height. Then this plt.plot, plot is a function which is going to plot the line graph. In previous videos, when we have to when we were expecting to plot histogram, then instead of plot we can go for hist. If you want to go for bar plot, you can go for bar, right? If you want to go for pie plot, then you can go for pie, and so on. For line graph, it's a plot, right? For which series you want to plot? For two series, two lists basically, the first and second. The first list is my Rs, so Rs is specified here. Second is response time 1, response time is 1, and so on. Label is basically server 1, which is going to display here, whatever label we are going to display. The color of this particular line is red we have chosen. You can give your color based on your requirement or your choice. Marker is basically O. This points are basically represented as O, or just like a bullets. If you want to give different, like for example plus, you can give plus. If you want to give star, you can give star, and so on. So let's give a star here. Marker size is 8, you can increase the size. Line style is the dashed, you can change according to your requirement. Line width also you can play with it. Transparency is basically the how much is the basically transparent this line where we want. So if it is 1, it will be completely visible. If it is 0, it will be completely invisible. And if it is 0.5, it's a 50% visible, and so on. X label is basically the name of x-axis. Y label is basically the name of y-axis. The title is basically the title for the graph. Legend is going to show the label. Label we have specified here, and this legend function shows the label. That's why this label comes here. And grid is basically, you can see the vertical lines here in the background and horizontal lines. This is grid, it is true, and we are going to show the graph. So let's execute this, and you can see this is going to say this marker is basically star now. Why? Because we have changed to star. If you are going to make as a plus, then it's a plus, right? The plus. If we are going to make as a O, then it is going to become let me just make it O, and so on. So if for example, if you don't want the grid, right, so you can just comment this particular line. So if I'm going to comment this line, if I'm going to execute, so you will not get a grid, and so on. If you want to change a color for this, if you want to make a blue color, then you can just play with color, and you can transparency. I'll change the value of transparency. We will set this value as 0.9. Then you can see this is now a little bit dark, right, compared to previous one, and so on. Line width 4. If I'm going to make 2, then we can just see. So this is going to become a thinner line, right? Not it is not having the previous width. It was 4, so it was very thick. So this is the way using which we can plot the line graph. Now let us see how basically we can go for multi-line graphs. So in our case, we have seen we have 3 servers, and we have recorded response time for 3 servers, and we will plot the line graph for each server with respect to hours. For example, for first server, hours versus response time 1, hours versus response time 2, and third will hours versus response time 3. So let's go here. So this is response time 2, which we have recorded here. This is response time 3, which basically we have taken from here. Why I'm not reading this Excel sheet, CSV sheet right now, because you might be not aware about what is pandas and how basically the CSV can be read. If you are aware about pandas, then just very straightforward one line code we can write to read this particular file, and we can you use that. So this is the second server response time. This is the third server response time, and again same. Now here this is the first. We are plotting hours versus response time 1, hours versus response time 2, and hours versus response time 3. And the label will be server 1, server 2, and server 3. And let's plot this now. What it is going to give an error is that name response time 2 is not defined because we haven't executed this particular line cell. So let us execute this cell, and let us run this particular cell now. Now you can see this is the line graph, multiple line graphs. Which shows the comparative performance of different web servers, and from this graph we can easily identify that the response time for server 1 is comparatively less than server 2, and response time of server 3 is definitely more than other 2, and so on. So if my question is which server is faster, right, then the answer of this question you can just post your answers in the comment of this particular video. And second question will be, which server is slower, right? Then you can also post the answer of this particular question into the comment box. Yeah. So I think this is enough for this video, right? If any questions are there, definitely you can you write your queries into the comment box of this video. I think this is enough for this video. If you found this video useful, you can like and share this video and subscribe the channel. Thank you very much.